We're going to try to cover a few things to do with series and parallel circuits here. Now, a lot of you will realize that this is on the right hand side. This is a series circuit, and on the left hand side, this is a parallel circuit. And because it's got, apart from this wonky bit here, which I've accidentally made, because it's got this classic sort of parallel light bulb circuits here, but the thing is, though, that is not the best way to determine whether or not it's a series or parallel circuit, because if I changed that and made it all weird shaped, it may not have the same sort of way of doing it as before. It is still a parallel circuit. So the thing that actually makes it a parallel circuit is these things here, which I'll draw now. That bit there and that thing there is the thing that makes it a parallel circuit. I call those, and they're probably the official name as well, a junction. And just as you said, just as my student here said, that the electrons go round here. If I close this switch now, there we go. The electrons are going round here, and then they get to choose. Some may go down to this light bulb, some may go down to this light bulb. And they don't have to. They could go to either one. It doesn't make. It's up to them, really. I'll say it's up to them. They're not obviously making decisions, but whereas in this case, all the light bulbs are going this way around. They're going through both light bulbs, and it's worth mentioning that again. In this one here, all the electrons go through both light bulbs. Now, because of that, they're going to use up more energy because they have to go through both light bulbs. So, light bulbs. So when you close the switch on both of them, you'll notice that these light bulbs are a lot brighter than these light bulbs, and that's because in this case, the electrons only need to go through one light bulb each, so they can use up all their energy on that one light bulb, whereas all the electrons need to go through both light bulbs. So, and so it's going to be a lot dimmer. Now, the battery on the left is going to not last as long because it's going to have to give a lot more energy to a lot more electrons a lot more quickly, and so it's going to use up its energy more quickly, but the light bulbs are going to be brighter. On the one on the right, the light bulbs are going to be dimmer, but it's not going to use up its energy as quickly, okay? That's right. So if I put two batteries here, it's gonna last longer. In fact, if I put two batteries in there, it would make it even brighter because they would still give more energy to the light bulbs. We're not going to do that just yet, though, because I want to focus on a couple of other things about this. So we're going to first of all look at how the voltage changes. Now, the voltage is the energy per charge. In other words, if we take a bunch of electrons, let's say 100 electrons, we want to say how much energy do those 100 electrons have, or how much. In fact, we don't really look at the amount of energy they have. It's how much energy they lose or gain between 2 points. That's why we have these two things here. So we might measure before on the one end, and then on the other end, and we can see that's 9 volts. It means 9 joules of energy per coulomb of charge. So a volt is a joule per coulomb. Okay, how much energy per charge? How many joules of energy per coulomb? So 1 volt is equal to 1 joule per coulomb of charge. Now, what it actually means is the amount of energy difference between the red one and the black one. I can measure before and after the battery, and I can also measure. I should do it that way around. So the black one was after, wasn't it? And that was negative 9 volts, and that's because it's lost the voltage, the volts. I've got 22 seconds to see if I can explain the difference here. In fact, no. Let's just do it on the next video. So anyway, so they use up all their energy on the light bulb as they go through there, and the same with this one here. Okay. All right. I'll just stop that.